Hello, everyone, and welcome back to Learn with Priya Singh. I am Priya, and today we are diving into the fascinating world of statistics. If you have ever wondered how data is analyzed, interpreted, and presented, then this video is for you. Let's break down it into step by step and make these concepts easy to understand. I hope everyone is ready. So let's go. Statistics. First question, what is statistics? So, statistic is a branch of mathematics that deals with the collection, analysis, interpretation, presentation, and organization of data. So, these are the five things: collection, analysis, interpretation, presentation, and organization is covered under stats. Whether it's understanding the average performance in a class, predicting trends, or making informed decisions, statistics is everywhere. Now, in statistics, we usually break things down into two main methods. First, as you see on the screen, descriptive methods and inferential methods. So there are two types of statistics. One is the descriptive statistics, another one is the inferential statistics. First, let us talk about descriptive statistics. So this is all about summarizing and describing the feature of a data set. Let's say you have a data set. When it comes to descriptive statistic, it means you are thinking of the snapshot of your data. You're just summarizing the features of the data. Okay. Second is the inferential statistics. So this is a bit more advanced. It is used to make generalizations or predictions about a large population based on a sample data. So we will be also studying about what is a population, what is a sample. But as of now, you understand that it is useful in making predictions about a large population based on a sample of data. For example, if you want to predict election outcomes based on a survey of just a few thousand people, for example, you just had elections, then you want to take out the survey results. So if you want to do that, you can do on a sample of a data set, sample of a population. So population is actually a true population is very difficult to take. Okay, so we always take a sample of the data, which is a representation of a complete representation of the population. Okay, so that is where inferential statistics comes into picture when we need to predict something. Okay, pretty cool, right? Okay, so now let's talk about the types we have under descriptive statistics. So in descriptive statistics, as you see on the screen, we have a laser highlighter. We have measure of central tendency and we have measure of variability. Let's start with the measure of central tendency. So these are the values that describe the center or typical value within a data set. बाबू मैम का मैसेज आ गया है. So these are the values that describe the center or typical value within a data set. The three main measures are, the first one is mean, median, mode, and we also have quartiles and percentiles within the measure of central tendency. So the three main are these, and then we also have quartiles and percentiles. So first one, let's talk about mean. So mean is nothing but the simple average. You add up all the values in the data set and divide by how many values are there. So total values divided by the number of values will give you the mean or simply the average. Second is median. So this is the middle value. When the data is arranged in ascending order, if you have an even number of data points, the median is the average of the two middle numbers. And if you have odd number of data sets, easily you can get the middle value. Okay. Third one is the mode. The mode is the value that appears most frequently in the data set. If no value repeats, we say there is no mode. And if two values are repeating multiple times, or these are the maximum number of times they are repeating, we say bimodal. Okay. And there are also multimodal, where you have got more than 2 modes available in your data set. Now, when we talk about data sets, we also have quartiles and percentiles. So quartiles that divide the data into 4 equal parts, Q1, Q2, Q3, Q4. We will also be studying quartiles in deep, but for now you can just understand that we are dividing the data into 4 equal parts. Whereas percentiles, we divide the data into 100 equal parts. So these help you to understand the spread and distribution of data even better. Okay. The next come, now let's talk about the measures of variability. These tell us about the dispersion of how spread out the data points are within a data set. Now, why this is important to study dispersion? Okay, let's talk about that. But first, we'll see the key measures of variability include the range, variance, and standard deviation. So range is the difference between the highest and the lowest value in the data set. It's a quick way to see the spread. So what is the minimum value from where it is spreading up to the maximum value? That's called range. Second one is the variance. So variance, this tells about the values in the data set differ from the mean. So variance tells about how much the values in the data set differ from the mean. A higher variance means the data is more spread out. Okay. The third one is standard deviation. So standard deviation is nothing but the square root of the variance. It's super useful because it gives you the spread in the same units as your data, making it easier to interpret. Okay, so these measures help you understand not just the average value, but how consistent or varied your data is. Okay. Okay, so let's talk about inferential statistics or methods. So these methods, they are used to make generalizations or predictions about a population based on a sample of data. So when you do all this, specifically how we select a sample from a larger population and the common errors that can affect our data. So let's study how do we take samples, what are the possibilities of errors, bias, what is point and range estimates, what is a CLT, central limit theorem, the most important and widely asked. Okay, so let's start. First one is, what is sampling? So imagine you want to know what people in your city think about a new restaurant. So you can't ask everyone. So what you'll do, you will take a sample. So a sample, it is a smaller group that represents the whole population. But how do you pick the right sample? So let's explore 3 common methods which are used to select a sample. So the first one is the random sampling. So this is the most unbiased method. Here, every individual in the population has an equal chance of being selected. So just take an example. Imagine you put 100 names in a hat and randomly pick 10. So everyone has a fair shot. Okay. So no bias, truly representative sample. When we say representative sample, everyone is getting a fair chance to participate or being represented. But yes, it's difficult when you implement this to a larger set of populations. Okay. The second one is systematic sampling. So highlighting the systematic sampling. So instead of choosing randomly, you select every kth person from a list. First, pick a random starting point, then keep selecting at regular intervals. So this is how you do systematic sampling. Say you survey every 5th customer in a restaurant. That's systematic sampling. Simple and structured, but yes, there could be a hidden pattern in the data and that could introduce bias while you pick the sample. Okay. The last one is the stratified sampling. Sometimes we need to divide our population into different groups or categories. These are also called strata. And then sample from each group proportionally. Okay. So you have the population, you divide into different groups of categories, which are also called strata, and then sample from each group proportionally. So if, for example, if you're conducting a survey in a school, you might divide students by grade level, kindergarten, first grade, second grade, and then select a sample from each. So the positive part of this is ensures representation of different subgroups. But yes, the cons are it requires knowing the population structure in advance. Okay. Next is the error bias. It refers to the inaccuracies or deviations from the true value or the state. So even with the best sampling methods, errors can creep in. So here are three common types of bias that can affect your data. The first one is the undercover bias, which is also called as undercoverage bias. Some groups in the population are underrepresented or missing from the sample. For example, if you conduct a survey online and you get the results, but the people who are not using the internet, they will be left out. So they will remain unpresented or represented or missing. Okay. Next is the exclusion bias. Certain data points, they are deliberately or unintentionally excluded from the analysis. For example, if a healthy study only includes young people, it includes older age groups. So you are unintentionally excluding or deliberately doing that. Okay. Third one is the survivorship bias. We only consider data from survivors and ignore those who didn't make it. So analyzing only successful businesses without looking at the ones that failed can give misleading conclusions. If you're going to only do your analysis on the successful businessmen, you are not looking at the hidden people who are already failed. So that comes under survivorship bias because it will give you misleading conclusions. Okay, next is point estimates and range estimates. So a point estimate is a single value you use to estimate a population parameter, like the average income, because it's just one single value. A range estimate, whereas, gives you an interval where you expect the true value to lie. For example, you will have a starting point, you will have an end point, and it will give you a range. Okay. So finally, we have the central limit theorem, which is properly also called as CLT. So it states that regardless of the population's distribution, the distribution of sample means will tend to be the normal, bell-shaped. We will definitely study deeper into the CLT. So what it is saying is, whatever it's a population distribution, but the distribution of the sample means, the average, it will tend to be normal, bell-shaped as the sample size increases. So this is huge in statistics and help make sense of data from various populations. Okay. So this was all about statistics. Statistics divided into two parts, descriptive and inferential. And then under descriptive, we have measure of central tendency, measure of variability. And then from inferential, how we get the samples out of a population to do predictions. So we have sampling methods, what errors can come, what is point and range estimates, and what is CLT. So wow, that was a lot to cover, but don't worry, you will get the hang on of these concepts with practice and in subsequent videos that I will be creating on each and every topic in broader sense. So statistics is all about understanding and interpreting the data to make informed decisions. And these concepts are just the foundation. So it's very important to understand these words, what is statistics, what is descriptive, what is inferential. Okay, so I really hope you found this video helpful. Make sure to like, comment, and subscribe for more content on statistics and maths. And if you have any questions or topics you want me to cover, just drop a comment below. Until next time, keep learning and keep growing. Thank you.